Okay. Hi there, everybody. Welcome to the September edition, the meeting of the Pass WIT chapter, our virtual chapter here. For those of you that didn't hear me a few minutes ago that weren't logged in yet, Pass Summit is coming up in October. It's the last week of October. If you haven't registered yet and want to, you should do so before this weekend. $9.18 is the price increase. And if you haven't registered yet, we'd love it if you would use the Pass WIT virtual chapter discount code. Saves you $150 off the cost of Summit. And of course, the WIT chapter actually gets credit for your attendance. So you can check us out. Pass WIT is on YouTube. This link will be available in the slide deck that we upload later. You can also just do a YouTube search of Pass WIT. Once this session is completed, we'll process the video and everything and upload it to YouTube, so you can always rewatch it there if there's a highlight that you think you missed. Check out our homepage, wit.sqlpass.org. This lists all upcoming scheduled WIT webinars, and we also highlight all women speaking at upcoming SQL Saturdays. So you can also join the virtual chapter from my chapters from the SQL Pass login. That way you get our monthly newsletter. I don't know, that typo has been there for months and I've never caught it. If anybody sees the newsletter is misspelled. So follow us on Twitter at pass_wit or use the passwit hashtag. Follow that. Also, if you guys have an article or a link or a blog or something that you think would be interesting to our membership, tweet that out with the hashtag passwit. We'd love to see it. A lot of us follow that. Special thank you to SQL Sentry. They have actually sponsored the Pass WIT virtual chapter for the entire year. Probably in our December meeting we'll have a short presentation from SQL Sentry once we get that arranged, but I really appreciate it. I mean, they could have picked any of the virtual chapters and they picked us. SQL Sentry also typically sponsors the WIT luncheon that we have at Summit. And we'll have an announcement about that luncheon coming up soon. So we're really excited about this year and how it's going to be slightly different than it has been in the past. So upcoming webinars, Melody Zacharias, October 12th. She'll be presenting Introduction to Microsoft Analytics, Tuning Data into Intelligent Action. She's done this session at a couple of different SQL Saturdays now. And we'll find out in a couple of days if she's going to be doing it at Portland, which is, of course, the week before Summit. So we have that to look forward to. Upcoming SQL Saturdays, Charlotte is coming up this weekend, and there's another one, another SQL Saturday that's this Saturday. Gail Shaw is presenting at that. I don't have links for it, so I apologize. In 2 weeks, SQL Saturday Dallas. That one, actually, one of their main organizers, Amy Harold, she's here on this list. So it's a SQL Saturday that's powered by some women, and so her session is on there. Naomi Williams actually runs the SQL Saturday in San Antonio, so we're slowly making inroads. That same weekend is Kansas City. Kansas City has a lot of female speakers. I'm one of them. My friend Monica Rathman is Melody Zacharias, who's doing next month's session. Kathy Kellenberger, who is my co-leader here of the WIT chapter. She's going to be presenting, but Kansas City actually has 2 slides. They have so many female speakers, so I'm really happy about that. Wendy Pastrick, of course, sits on the PASS board. So today's topic, Shabnam Watson, is going to cover a SQL Developer's Guide to MDX. This is the description that's been on the webpage. We rescheduled this one, I think, from July. Is that right, Shabnam? Was it originally July?
Yes, it was in July.
So we rescheduled this one from July, so I'm really glad you guys decided to join us. We appreciate it. So that's all I have right now. I'm going to go ahead and turn this over to Shabnam. And if any of you guys have questions or anything along the way, feel free to post them there in the GoToWebinar, and I'll either pause or hang on to them as need be. So thanks a lot, Shabnam. I'll let you go ahead and go.
Okay, thank you, Ree. Give me 1 minute to share my monitor, and let me know when you see it.
I see it. I'm good. I had muted my microphone. Sorry.
Okay. Thank you, Ree. Hello, everyone, and welcome to today's session. My name is Shabnam Watson. I am a BI consultant. I have worked with SQL Server family of products for the past 15 years with a focus on analysis services. I help data warehouse teams with SSAS implementations, authoring and optimizing MDX queries and calculations inside the cube. My introduction to SSAS first came through learning how to write MDX queries. Back in 2002, I was working as an application developer programming against SQL Server 7 when I got responsible for a module that queried a cube. At the time, analysis services was called rollup services. I had to learn how to write custom MDX queries to get the data out of the cube and display it in the custom GUI that we had. Later on, I moved to a full BI role, having come from a developer background and learning the MDX queries first. It helped me a lot because as I was designing the cubes, I always had in mind that I have to support queries coming from all different kinds of outside tools. SQL and MDX have many keywords in common, but they're also very different at the same time. In fact, the keywords that they have in common a lot of times can throw you off when you're getting started. So, another human language. You have to turn off your SQL brain for a focus on the meaning or the results that you want to get and work through MDX, knowing that your data is sitting in analysis services and now you want to get it out. So today I'm going to show you how to do that. We're going to look at SSAS in multidimensional mode from a query perspective, meaning that we're just going to focus on its data structures, measure groups, and dimensions. And then we're going to look at a couple of queries, MDX queries, and compare them side by side. Then I will show you the execution stages that an MDX query goes through as it hits the engine. And then we'll switch to demo mode and we will work through more MDX queries. So in a data warehouse, data is stored in a set of tables, fact tables and dimension tables. Fact tables contain your numerical data and dimension tables contain your attributes by which you can slice and dice your numerical data. For example, you can look at fact internet sales from the AdventureWorks sample database and look at your sales by months or by customer demographics. When this data is pulled into analysis services, fact tables turn into called measure groups. Query, you look for a measure is going to be into dimension objects and data structure called a cube. So if you're looking at AdventureWorks sample database, fact internet sales turns into internet sales measure group. The customer turns into the customer dimension, and then the cube is called AdventureWorks. For example, the sales amount column from fact internet sales turns into the internet sales amount that you can see here within the brackets. That's called a measure. So two things to keep in mind. Once this data is loaded in the cube, the relationships between the tables or objects is already defined for you. This is something that's done at design time by the cube designer. At query time, you don't have to worry about it anymore. The other point to keep in mind is that the measures or numerical values have a predefined way of summarizing. So if you ask for internet sales amount for all products or all customers, it already knows that it should sum it up or take a min or a max. Whatever it is, at query time, you no longer have any control over it, unlike SQL. The measures are easy to understand when you're coming from a SQL mindset. So measures equal to one column in your fact table. The dimensions are a little bit more complex. So let's take a look at dim customer. I've taken 3 columns from dim customer with just a couple of sample rows. So SSAS at processing time brings this information into a dimension object. Let's see what it does. It submits select distinct to each column that you want to bring in. So for first name, it will take the individual values. For last name, it does the same thing for occupation. Once it does that, it puts them into these objects inside the dimension, which are called attribute hierarchies. So each column from your table that the designer chooses to bring into analysis services turns into an attribute hierarchy. Now, why is it called a hierarchy? That are inside each one, you can see that there is a parent called all first names or all last names or all occupation, and then there are the individual values that it got by submitting a select distinct to SQL Server. This all level member is built implicitly. So if you're just creating the cube and just bring in columns from your table, dimension table, it creates that all member for you automatically. So it's easy to miss it, but it does exist. So at query time, you just have to be aware of that this member does exist, and if you want to reference it in your queries because you just want to get a summary, it's very easy to do that. So there's an all level attribute hierarchies, and then there is the actual individual level. So if you look at the customer dimension, I'm going to use the customer. So let's take a closer look at it. This is the occupation attribute hierarchy. A lot of times you will hear people will miss the hierarchy. So here, this is the occupation attribute, but it's really a hierarchy. It has 2 levels. It has an occupation level. Now notice that the name of this level is the same as the name of the attribute hierarchy. This can be confusing when you're writing queries because you're going to see that the word occupation is going to repeat twice. Now knowing this, you're going to understand why you see it twice later on. This all level does exist for all attributes inside the cube unless from here, I have to move all the way down to here and ask for members. So I go customer, occupation, occupation, dot members, which is one of the first functions that you should learn in MDX. It returns a set of members of a level or a hierarchy.
Shabnam?
Yes.
I think I lost audio for a second or for a minute or two. And I now can't see your screen because I had to reconnect. Can you just make sure? I don't know if anybody else is connected at this point. Can you, hold on, I had a question. I had a hand up and it went down. I just need somebody to let me know that can hear me on the call if you can, hey
It
guys,
seemed like it
hold
stopped
on,
sharing.
I have a lot of people okay, somebody says it's back on now. Okay, good, we
Okay.
got it. Thank you guys very, very much. I couldn't hear her for a few minutes and I started working on it and I had
Which slide was it that you lost the audio?
I don't know, go back a few.
Okay.
One more. There.
One more.
I lost
Here?
audio there.
Okay.
So
Okay, so I guess
somebody
for
says
those who lost the audio.
they say they lost at 7 and I think this is 6, right?
Okay. Okay, so let's go back to 7. Okay, so looking at DIM customer, the individual items that you see called attribute hierarchies. These columns from SQL Server that got imported into analysis services. Now, if you look at the occupation, the example that I've handed, you can see that all customers are listed and an individual value. If I want to get just the individual, I have to go down to the occupation level. In Management Studio, when you're browsing the keys, you can see whether it's a hierarchy or a level, it will tell you. Again, this is a syntax to reference a level or a member. Here, for example, we mentioned the name of the dimension in brackets, then the occupation, which is the hierarchy, attribute hierarchy, and then the level occupation and its list of members. In addition to attribute hierarchy, so each column comes in and turns into an attribute hierarchy, there's another kind of hierarchy called a user-defined hierarchy. The user-defined hierarchy is easier to understand. It's more like a navigational path or data roll-up. So a good example of it is in date dimension, where date rolls up to month, quarter, to year. And similar to the attribute hierarchy, in order to reference a member, you have to specify the same syntax. We use the same syntax: dimension, hierarchy, level, individual, members. An MDX result set looks like a grid when it comes back to you in Management Studio or any other tool that you're using. It typically has columns and some rows similar to a SQL result set. So things that you put on the column, obviously there are going to be columns, and rows are rows. Each one of these is called an axis: the columns axis and the rows axis. A query has to have columns before it has rows. You can reference these by their keywords or the numerical values. Now the list goes on that this can have more access. SQL Server Management Studio is limited only to 2. Most tools are, but if you're writing a .NET application, you can specify more access and consume that data set that comes back. Okay, so let's look at a very simple query. In SQL Server, if I want to get the total sales amount from fact internet sales, this is how I write the query. I specify the name of the fact table, the name of the column, and price. This below get from the MDX, I do that. So we know that measure, in this case, internet sales amount. This is how the query looks like. It starts with a select similar to the SQL query. Then it's the name of the measure, what you're asking for. In this case, the syntax is the word measures inside brackets and the name of the measure inside brackets. That's how you reference a measure. The curly brackets, they signify a set. So you can have a set of measures on the columns. You can have more than one column. In this case, we only have one item on the column. And then you specify with the keywords on columns where this is going to be, because an MDX result set has axes, different axes. The from clause, notice how the from clause is just the cube. So you no longer need to group this measure. Another difference is that not specify how internet sales should be summed up over all values. It is already predefined for you. So let's look at a different query. This time, this is the result set that I would like to get back from the SQL query. So I want to look at sales amount by English occupation. Just think about it for a second before I show you the query in your head how you would write that against AdventureWorks. So we have a fact table that contains the numbers. We have a dimension table that contains the individual values of occupation. We have to join them together. We have to know which columns to use for the join, and then a group by and a sum. This is the query. Now, the same result set is shown below from the MDX query when it runs. This time, similar to the previous query, so we want to put a measure on the columns from the cube, but this time there's something on the row, so we're going to specify items to go on the row axis, which are the members of the occupation level. Let's take a look at that. The columns part is similar to the previous query. The from part is still the cube, similar to the previous query. And now we have a comma at the end of the columns, and we have the rows axis. And now that you look at this, you know why the occupation is here twice, because I intentionally did not want to get that all row back in my results set because I was trying to match the exact SQL query results on the top. Here is where MDX starts to become simpler than the SQL query in some ways. You don't have to specify the summary function, and the from clause stays the cube. You don't have to specify the two tables going against each other because that work is done for you in the cube and hopefully was done correctly so you get correct results back. So before we switch to demos, I will show you the parts of the MDX query and how it goes through the execution stages. There's a select statement, there's a select keyword to indicate that the query is about to start. Then a set of things go on columns. They can be measures, they can be members of an attribute from a dimension. Similar with on rows, you can have things that go on rows. You can put measures on rows. You can put members of a hierarchy on the rows. The from clause is the cube. It stays the cube for most queries. When you get into more advanced queries, this can be a subcube. And then there's a where clause, the where keyword that we're familiar with from SQL. It's a little bit different than SQL, however, it does the same thing. It puts a restriction on your query. This before the main part of the query, which starts with a select, there is a with set calculated member option available. So if there is a calculation that is not available in the cube for you for whatever reason, at query time you have the option of creating it for the scope of your query. Now, when this query goes through the engine, the analysis services query engine, it's resolved in a certain way, in a certain order. First, the from part is resolved. Which cube are you going against? Then the where clause, which is called also a slicer, is resolved. Then the with set or calculated member is resolved. So whatever restrictions you put in the where clause affects your calculated members in the beginning of the query. Now, in most cases, that is the desired effect. However, sometimes that's not what you want to do. You don't want that to be affected by the where clause. So in those cases, you have to be aware of it and do something else. And then at the next step, the axes are resolved, the rows and columns. Now, here's the tricky part. At this point, the rows and columns are resolved independent of each other. It figures out what's going on the columns, what's going on the rows, but it doesn't care if they do exist with each other. So if there were some products that were never sold at certain warehouses, it doesn't know that yet because it hasn't put them through the measure groups. So unlike SQL, you can get things that do not exist with each other, so you will end up with some empty cells in the middle. And at the last step, it figures out the cross-section to see what are the numbers that it needs to display in the middle, and then the results come back to you. I am ready to switch to demo mode and go through some queries. So Ree, if you want to see if there are any questions, we can pause for a minute and answer questions. If not, I will just go ahead to the queries.
There are currently not any questions, other than the 25 messages I got about losing the screen and getting it back. So those are all resolved.
Okay. Okay, so in SQL Server Management Studio, you can write your own custom queries. Similar to SQL Server, you can get a connection to Analysis Services Engine. You just hit connect, and then you get this pane on the left where you can see we have under the server, there are databases. There's a concept of databases. In this case, I only have one database called AdventureWorks, and under that I have cubes listed. So if you right-click in, say, Browse, you get a browser that looks like this. At this point, you can just drag and drop and form your queries. You also have the option of exporting this in Excel and opening up in Excel and continue your work from there. In order to open a new query, you can just say New Query, click on New Query or MDX. Either one is going to open a query window for you with a browser on the left. So here you can see that in AdventureWorks, this is the list of the measures. If you go under Internet Sales, you can see the individual measures, and from this point you can just drag and drop. So if I just drag and drop, it populates that format for me. So it says measures and name of the measure. And then below the measures, you get a list of the dimensions available. This first one that I'm looking at is the customer dimension. And if you go down, this is the occupation attribute hierarchy. So see if I mouse over, it says attribute hierarchy, right? And if I look at the members, I see that there is an all customers available here. And this one below, notice how it says level occupation, so this is a level. All right, so this is the first query that I showed you, sales amount on the columns and the occupation members on the rows. And here's my result set. So what happens if I take the second bracket off? Let's take a look. Now I have an all customers member showing up. And I've also changed the keywords, columns, and rows to 0 and 1 just to show you that that's another option that you have. Okay, so building on the first query, we had internet sales amount on the columns, Now I want to add another measure to it. So all I got to do is put a comma at the end of the first measure and specify the second measure. And they are enclosed in curly brackets to specify that this is a set. On columns, this time on the rows, I'm switching to a different dimension attribute. I'm looking at date dimension, the calendar hierarchy, the calendar year level, and I'm interested in all the members that are in that level. So if I just highlight this and I run it, I get the internet sales amount and reseller sales amount by year. Now think back to SQL. If you were to write this in SQL, you had to join two fact tables. Reseller sales amount is coming from a different fact table than internet sales amount. Writing this in SQL, you have to cross through the dim date, bringing up both of them to the same level and then joining them together. Here, from a relationship-wise, it's easier to write. So once you get used to the syntax of MDX, this part of it is easier. Now notice how the last two rows are empty. This is because there was no sales associated for 2009 and 2010 in this sample database. And this is also because the rows and columns are resolved independently. It doesn't know that they don't exist with each other. It will just, at the last minute, it will check and they're empty and it will show you the results. So if you want to get rid of that, you just add a non-empty in front of your rows, the set that's going on the rows. Non-empty can go in front of any set. And if you just run that, the last two rows drop off. Next query, similar to listing individual members on the columns, you can list individual members on the rows. So far I've been using the members to get all the members out of a hierarchy or a level of a hierarchy, but I can also reference a particular member. I can say calendar year 2005 and 2006, and also the all member of the calendar year. So if I run this, I'm going to get 3 rows back. And the total doesn't match. That's intentional. I just want to show you how you can ask for the all level. This would be useful in cases where you're creating a ratio to the parent. Next query shows you how to add a where clause. So that's the next common thing with SQL queries. This is the first query that we ran. Sales amount by occupation from AdventureWorks. So what if I want to restrict this to calendar year 2008? The where clause starts with parentheses, open paren, close paren, and your criteria in there. Unlike SQL, there is no where this column equals that value. You just reference what you want it to be. So this is saying where calendar year equals calendar year 2008. And this syntax, you don't have to memorize this. This pane on the left gives you help. So let me close customer, go back to date. And this is a display folder just to organize the attributes together.
Hey,
and this,
let me,
yes.
Shabnam, before you go any further, someone has a question. They ask, what is a default member and what is a default measure?
Okay, so if you do not specify an all member for a dimension attribute, then you have to specify which one of it it's going to default to. So if you're getting reports, for example, out of a cube and you have different option of getting in different reporting currencies, and if you don't specify in your query which reporting currency you want to get it from, well, it has to, by default, return it in one of those reporting currencies. It cannot return it in, let's say, US dollars and Canadian dollars at the same time. So whoever designs the cube for each attribute has defined either an all member or a default member. So that's a default member. The default measure of a cube is the measure that if you do not reference any measures in your query, you can write queries without referencing any measures. So you can say, put occupation on the rows and calendar year on the columns. You don't have to put a number in, you do not specify a measure in there. There is a default measure that comes back from the cube. It may or may not be what you want. It may not be related to the dimensions you're even querying. So that's the default measure of a cube.
Thank you.
Okay. Sure. Okay. So this here shows the calendar folder. Underneath it, you see each one of these is an attribute hierarchy. When I get down to here, date calendar, it says just a hierarchy. So this is a user-defined hierarchy. From a query perspective, it doesn't make a difference for you whether it's a user-defined hierarchy or an attribute hierarchy. You just have to be aware of them. Basically, both of them have levels. One always has 2 levels. The other one can have multiple levels. So date calendar, and then I was interested to get the members of the calendar year underneath 2008. So if I just go here and I drag and drop this, it puts this member for me here. Now, when I drag and drop it, it referenced this ampersand is referencing it by its key value. I like to put the actual name in there so I can change it to calendar year 2008. Okay, so if I run this, now my result set is limited to 2008 only. Okay. Now, something interesting that you can do in an MDX query is that you can put the measures, the measure in the where clause. Because as far as analysis services concerned, the measures is a dimension by itself. You can think of your data only in terms of your sales amount or your inventory dollars, either one. So if I change the internet sales amount from being on the columns to going into the where clause, and I bring what was in the where clause of 2008 on the columns, and if I run the query, I'm going to get exact same numbers in the middle of the grid. What's going to change is the title of this column. Now it's going to say calendar year 2008, but what's actually inside is the internet sales amount. Why would anybody write a query this way? The reason I bring it up is because this is how Excel submits queries. When you only have one numerical value specified, this is how the queries come. Sometimes in reporting services, when you want the column to just be called calendar year 2008 and you know there's sales dollars in the middle, you may choose to do it this way. Okay, so going back to the query that's easier to understand for human brain, which is the measure is on the columns here, and the occupation values on the rows. This time I want to add a second criteria. So the way to do that is inside the parentheses, I start specifying my criteria. So 2008, similar to the previous query, comma, this time I'm only interested to see the sales dollars for the category of bikes. So I just separate that by a comma, close print, and I run it. So this is only for bikes for 2008. And now, you know, what you don't see here is that every other attribute that is not specified in this query is actually taken into consideration. So for most of the attributes, their default member is the all members. So if you don't put a restriction on them, if you don't say what's their geography, what was the sales geography, basically you're saying, I don't care, return me all the sales dollars for whatever the geography was. So essentially you're asking, return everything for me where the geography is all, everything. But for attributes where they have a default member, like if there were a reporting currency in here, the member that's included in here implicitly behind your query is that default member, so we'll return the US dollars, for example. And this next query, I'll just show you how, if you want to add on to the where clause, this time within the same attribute. So the year is 2008, but the category is bikes and clothing. So after the comma, still within the parentheses, inside curly bracket, you can specify a set, which is the categories of bikes and clothing together. Another important concept to learn with MDX queries is the concept of a tuple. Let's look at this first query, go back to the same query, and I'm going to make this a little bit more complex. I'm going to introduce the idea of tuples to you through calculated members. So I'm interested to add a second column to this query that, to get started with, just going to be an exact copy of sales amount. This is how I add that. Before the body of the query, I say with calculated member measures the new name I want to give it as, this is where the definition is. Here the definition is just internet sales amount, so it's going to create a copy of it. And then in the body of my query, I'll just reference that. So if I run this, now I have two columns that are exactly the same. So not very interesting. The next query, this time I'm interested to see the sales amount for calendar year 2005 and calendar year 2006 on the columns next to each other. So one way to do this is to create two calculated members, which are measures in this case, one for 2005 internet sales and one for 2006 internet sale. The definition is as follows: parentheses, inside parentheses, name of the measure, comma, what criteria. So this together is called a tuple. A tuple is like a where clause, essentially. You're saying, give me the internet sales amount where the date, calendar year is 2005. Similar for 2006. This is a tuple. Now if you learn how to write tuples, you can create most of the calculations inside the cube. Now we're looking at analysis services from a query perspective, but you can do most of this from inside the cube also. So if I run this, now I have two columns sitting side by side that show me the 2005 and 2006 sales amounts. And one step further from here, if you want to take the query one step further, a more interesting example is a query that would return the sales amount for current year and the sales amount of previous year. How do you do? So this is the main body of the query. We want to select sales amount and this measure that we're going to build, the calculated measure next to it on the columns, and calendar year members on the rows. Now how do we build that member, last year's internet sales amount? You specify it with calculated member, name of the measure, and then its definition. Inside parentheses, so we want measure internet sales amount where we don't want it for this year, we want it for last year. So what I'm telling it is, go to the date dimension, go to the calendar hierarchy, remember the calendar hierarchy here, and whatever the current member is of the calendar hierarchy, because I'm going to put the calendar hierarchy on the rows, whatever the member is, go back to the previous member. Now this is optional, this is implicit, you don't have to put in your query, but it makes it easier to reach. So you can just say previous member, but it's easier when it's there for me to read it and understand it later. So if I run this, I get this grid. So let's walk through this. As this goes through the engine, it first figures out what are the labels that are going on the columns, sales amount and last year sales amount. What's going on the rows, the individual calendar years. And then it goes inside in the last step and figure out what's going in each cell. Well, this cell is coming from internet sales amount. This cell has a calculation that goes to it. So it goes and figures out the calculation. So let's start with this cell for 2006, last year internet sale. It says, for this cell, get the sales amount where the year is, whatever the current year is, minus 1. So the current year for this cell is across from it, 2006, and go back one member. So that's the sales amount for it that it fetches. So the numbers match diagonally here in this grid. And this is one of the powers of MDX, utilizing the hierarchies that are built in for you, which makes it very easy to navigate around in these hierarchies. This is the last query that I want to show you today. From here, I'm going to switch back to Excel and show you how you can look at queries that are submitted against analysis services, because if you're learning to write queries, a lot of times you can look at other people's queries that they're submitting and the examples and what functions they're including can build on your function vocabulary from there. So this is Excel connected to AdventureWorks. I got here by clicking on Analyze in Excel button. That's a shortcut to get this Excel book all ready for you connected to AdventureWorks. So looking at sales amount by occupation values. There is a tool available that's free for download. It's an add-in for Excel. It's called Pivot Table, rollup Pivot Table Extensions. Once I install that, when I have a pivot table connected to the cube, if I right-click in the grid, all the way at the bottom, I get an option that says rollup Pivot Table Extensions. This tool can do a number of useful things. What I want to show you here is the MDX tab. Here you can see how Excel is forming its query to send to analysis services. If you're connected to internet, you can choose to have it formatted nicely using a web service. Else it'll all be gray and one continuous big line. So you can see that Excel chose to write this query different than what we were doing. The from clause is AdventureWorks. Look at the measure. The measures in the sales amount. The measure is, in the where clause. If you have more measures, they will not go in there. It will do something different. And notice how Excel is using different functions. It's choosing to drill down the customer's hierarchy from the all member. And then there's a bunch of properties at the end. These are just properties. These are extra properties. If you right-click on a cell, it will just show you those properties within Excel. So this is one way to look at the queries. Another way to look at queries is just by running the profiler and getting a trace. So similar to running a trace against SQL Server, you can start a trace, and the server type, you choose analysis services. And from the event selection, there's many events where you can get the query. One of the places I like to get it from is you can get it from progress report and begin, but one of the most straightforward is from the query begin, and I will just uncheck everything else and run it. So if I go back to Management Studio and if I run this query, it will show up in the profiler. So You can do this to look at the queries that other people are running against analysis services, again, if you're trying to add on to your analysis services vocabulary. Okay, so let's switch back. I'm going to switch back to the slides. Just to review, focus on the results at the grid, and then remember that your numerical values are sitting in measures, your attributes are sitting inside dimensions, inside attribute hierarchies. And think about the order that your query is resolved and how the cells are the last thing that get populated in the middle. And from there you can add on to the sets that you put on the columns and rows. So MDX is a set-based language. You can choose to put certain products on the rows, certain things on the columns based on additional criteria. There's many more functions to use. Where to go from here, some useful functions are cross-join and filter to look up next. I have a couple of references for you. Both of these books are older books, but they're very useful if you're trying to learn MDX. For Analysis Services Multidimensional, the first book, MDX Solutions, has a function reference at the end of it that I have used throughout the years. And this function reference for each function has a little example, a little picture, especially when you're learning about those navigational functions. It's very useful, but it's only focused on MDX. This will not teach you about Analysis Services Multidimensional. If you're trying to learn Analysis Services Multidimensional, one of my favorite books is Applied Microsoft Analysis Services 2005 by Theo Lachev, and also there is an MDX language reference available online that is very thorough and has a lot of examples for you to go through. So thank you so much, and Ree, if there are questions, let me know.
So there are a few, and one I was able to answer. Someone wanted to know the correct spelling of tuple, although you and I pronounce it slightly differently, and there's a whole, it's like GIF and GIF.
Right.
And if you've never heard the phrase before, you don't know that it's T-U-P-L-E.
Right.
So if you needed to Google and look that up, that's how. Let's see.
Correct. T-U-P-L-E. Yes, correct.
Right. So I have a question here. Why does Excel write MDX queries differently?
Excel has to generate queries automatically or programmatically. It's not like it has to be able to answer queries based on what you put on the rows, you put on the columns. And it has to be able to generate those queries based on the selections you do on the screen. So if you write this from a program, which I did years ago, I wrote a browser that is very similar to what you see in Excel. You have to generate a large number of queries in a certain way, no matter how the query is. So that's partly what the reason is for that.
Okay, so someone asks, is there a website where they can find a list of MDX queries to use for practice? Now, I would think this might be more specific to your data set, but...
Yes, so the online reference, the MDX language reference off of MSDN has all the functions listed with little examples. That's a great place to go. And also in Management Studio, as you're writing queries, there is a Functions tab available. If you can still see my screen.
Yes.
There's a Functions tab, and it lists all the functions that are available to you, set navigation functions. And there's not a real help here. It'll just give you what the thing to get are. It says it's supposed to get a member and a distance. And you can just go to the all, which is where I usually go because I don't remember which one's exactly in which category. And that's where you get the list of all the functions.
Okay, and where would you recommend somebody get a resource on performance tuning MDX queries on big SAS cubes?
There are a couple of white papers available out there from Microsoft, so you can look up best practices, and those white papers has tips available for you for performance tuning. Also, if you read some of the books that go inside the analysis services engine and talk about its storage mode or how things are stored on disk in the case of SSAS, it will help you understand what's going on behind the scenes better. Other than that, there's a lot of blogs available, so just search for performance tuning best practices, and there's a lot of blogs available and articles written by different people that will help you through.
Okay, well, so that's the end of the questions that we have for today, unless another one pops up and I don't see it. Thank you very, very much. We are right at the hour mark. I want to remind you guys that this session has been recorded. We even recorded the little break and, and picking it back up. But this session's been recorded. We'll get this processed and uploaded to our YouTube page, hopefully later today. Additionally, any previous session or any future session also gets recorded. And if anybody on this particular session today is coming to Summit, I think on Friday of Summit there is something called the Birds of a Feather luncheon. And that's where people go and you pick your table at lunch based on what you want to talk about and what the subject of that table is. I've asked Shabnam to moderate a table there. I'll be moderating a WIT table there. So even if you don't want to stay and hang out and talk to me, come introduce yourself. I'd love to meet some of you guys, some of you ladies as well. So if you get a chance and you're at Summit on Friday, and then of course don't forget there's the WIT luncheon that we sponsor, and SQL Century is the sponsor this year. So come and find us there. Thank you very, very much for attending today. We really appreciate it, and if you guys have any questions, reach out to either us on Twitter or our email address that's always available, and we'll see what we can do about getting something answered, even if you had follow-up questions. So thank you very much, and you guys have a great day.